the vertical structure of the ocean. That's what we're going to talk about today. Okay, so we're going to be doing this lab, and you're going to follow along and answer some questions, okay? Okay, so if we read our lab, it tells us that the density of seawater plays a really important role in causing ocean currents, right, in causing water movements. And we learned in our lecture that even though we tend to think of the ocean as just kind of this one giant body of water, it's actually layers, right? And those layers stay pretty well separated in part as a function of density. So we're going to look at how density works in terms of stratifying the ocean and in creating that vertical structure of the ocean, right? We've talked about the atmosphere and how the atmosphere has its own vertical structure. And now we're just going in the other direction, and we're going to talk about how the ocean also has a vertical structure, and it's largely based on density. So if you're reading through your lab, right, which we'll do now, it tells us the density of seawater plays a vital role in causing ocean currents and circulating heat because of the fact the dense water sinks below less dense water. Salinity, temperature, and depth all affect the density of seawater. Density is a measure of how tightly a certain amount of matter is packed into a given volume. The more the stuff is packed in, the higher the density. Seawater contains more than a dozen different ions, those are charged atoms you'll remember from chemistry, that we call salt. These salts add to the mass of the seawater, increasing its density. For example, seawater is denser than freshwater. Density can be calculated by dividing an object's mass by its volume, and it's commonly measured in grams per milliliter or grams per cubic centimeter. Deep water is denser than shallower water. The water molecules are packed together more tightly because of the weight of the water above that is pushing down. Dense water sinks below less dense water. This is the principle that drives deep ocean currents that circulate around the world. So a combination of high salinity and low temperature near the surface makes seawater dense enough to sink to the bottom of the deep ocean and flow along the bottom of the basins. Okay, so now we're going to start our experiment. And the way we're going to start is you can see all of our items there. We have 3 different solutions. We've got our green one, our yellow one, our red one, and our blue one. Okay. So you don't know which is which, but one of these is a 0% salt solution. Right? We would expect that to be the least dense. Then we have a 5% salt solution, a 10% salt solution, and a 15% salt solution. We also have here, we have our beakers where we're going to pour each one. We have our test tubes, okay, and our pipettes that we're going to be using for our experiment, one for each solution, and we have paper towels because sometimes we're sloppy and we need paper towels. So during this lab, you will determine the percent salt concentration in each of these. You're going to figure out which is which, okay, based on its density and how it behaves relative to the other colored solutions. You will observe stratification of the water column based on different densities, just like we talked about. When the layers are properly oriented, that is the less dense on the top and the more dense near the bottom, they will not mix. So you have to repeat the experiment until the layers all remain stratified. And here we go. The first thing we're going to do is we're going to take a little bit of each solution. Again, we don't know what concentration they are. We're going to give the container a good mix. We're going to pour each solution into the beaker. So when we're using chemicals, we don't want to use from the original container, right? Because we don't want to contaminate that. We want to pour a sample that we're going to be using. So I have some of my blue. I'm going to put my stock back. Pour some of our red. Oh, this is why we have paper towels. Pour some of our green. And pour some of our yellow. So now we will have each of our 4 concentrations. Remember, one of these is 0 salt. One of these is 5% salt. One of these is 10% salt, and one of these is 15% salt. And we would expect the water column to stratify based on density. So we would expect the more dense, just like in the ocean, to be at the bottom, and the less dense to be at the top. And this is why we have paper towels. Okay. So once we've cleaned up our space and we're kind of ready to go, we can get started. Okay, so here we have our test tubes. And I've got a few just so I can work consistently. And I'm going to use the same dropper for each. I'm going to use 1 dropper per solution, right? Because I don't want to contaminate something with the wrong concentration. So I'm going to commit these droppers to these solutions. And so here I go. We've done step number 1. Into each of 4 beakers, pour a small amount of each of the 4 colored solutions. Here we go. Using 1 pipette for each solution, take up a small amount into the pipette. Place the tip of the pipette against the wall of the test tube and release the contents into the tube. Repeat this with each of the other solutions 1 at a time. Use a different pipette for each solution. Remember, we don't want to mix our pipettes because this will affect our results. And observe if the layers stay stratified or if they mix. If they mix, we know we got them in the wrong order. Okay, so we've got to start over again. We want to continue until we get 4 distinct layers. Remember, we're trying to figure out, based on density, which salt concentration is which. So I don't know which is which, right? I got to start at the beginning, so I'm just going to guess. I'm going to start with the yellow. I like the yellow. Yellow's pretty. It's sunshiny. So I'm going to take some yellow. The reason we let it run along the side is because it delivers a steadier stream of liquid into the test tube. Okay. So here I've got some yellow. I'm going to add a little more. All right. I don't know what concentration of salt yellow is. It could be 0%, 5%, 10%, or 15%. If it's the most dense, it's going to stay at the bottom. And if it's the least dense, it's going to get mixed up. Okay. What should I use next? Maybe try the red one. Okay. Again, I want to do this gently. So is the red going to stay on top of the yellow? Oh no, they're mixing. Oh, they're mixing. There's no stratification there. Right? They're all mixed up. Okay, so clearly the red is more dense than the yellow. Right? Because they mixed. So that's not going to work. I'm going to put this one over here to dry. Okay, so I know that the red is more dense than the yellow. Clearly. All right, so let me try this again. I'm not going to go with yellow first because that was not right. So the red is more dense. Maybe I'll start with the red. Should I start with the red? Okay, let me start with the red. All right. A little more in there. So there's a bubble. There's my bubble. Okay. So there's the red. So I know the yellow is less dense than the red. So let me see if I can get those to stratify. If I can get them to stratify This way I'll know, that I'm right, that the yellow is less dense than the red. I want to do this gently though, because you can see how if you go too fast, you'll kind of stir it, and that's not what you want to do. Oh, wow, look at that. Well, there's a little bubble there. Can I get rid of the bubble? Hang on, I'm going to try to get rid of the bubble. See how there's a really nice line there between the red and the yellow? So I know the red is denser. That is beautifully stratified. Look at that. All right. So the red is denser and the yellow is less dense. Okay. So is blue going to be less dense than yellow? Remember, I'm still trying to figure out my concentrations. Again, I'm going to do it gently because I don't want them to mix. Oh, no, look. My blue and my yellow all mixed up, so I don't know which is which now. But see how the red is still at the bottom? How cool is that? Okay, so I know that red is denser than the blue or the yellow. And I also know that blue is denser than the yellow because it didn't sit on top. Okay, so red is densest, blue is less dense, and yellow is less dense again. So I'm gonna dump this out and try again. Okay, so now I know that the most dense of those three anyway is the red. All right, let's get the red in there. Oh, we need more red. Okay, remember how last time we did yellow first and then blue, but the yellow and blue clearly mixed? All right, so this time I'm going to do blue. Slowly. Let's do a little more blue. Okay, see how we have red, then blue above it? Nicely stratified. All right, now let's do the yellow, because again, we're pretty sure, right, that the yellow is lighter than the blue. It's less dense than the blue. Get a little more yellow in there so you can really see it. Yeah, and there we are. We got red, blue, and yellow at the top. Red, blue, yellow. Can you guys see that? My shirt is plaid, which isn't helping. Do you guys see that? Maybe behind with the paper towel behind it. Right? Red at the bottom, blue, and then the less dense yellow on top. Okay, awesome. So remember what we were trying to figure out was one of these is 0, one of these is 5, one of these is 10, and one of these is 15% salt. But we've only got 3 so far, right? So we know red is denser than blue and blue is denser than yellow. But what about the green? I don't know what the green's gonna do. All right, so we have our really nice layers there. All right, so now let's try adding the green, because we still haven't figured out where green goes. And unless green is the 0%, which is possible, right? That'd be nice, because then then we'll have figured it out. So let's see. Oh, no, 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 they all turned green. The green mixed with everything. Except the blue, right? So the blue is still the red is still definitely at the bottom. So the red looks like the densest of all of them. And then the blue, it looks like the green didn't really mix with the blue, right? Ah, but it mixed up with the yellow. So maybe I just need to flip my yellow and green. So maybe, right, so we're pretty sure that red is the densest. So let's do this. Oh, this could be our last one. Let's see if this works. Is red our densest? Let's try it, guys. So red is our densest. Okay, and that blue looked still pretty blue. Like, I don't think the green mixed with the blue, so I think blue might be our next densest. Do this kind of slowly so you don't agitate the water. Okay, here we go again. Yep. Okay, so red is definitely denser than blue, right? Okay, so last time we thought yellow was the next least dense, but the yellow and the green mixed. So let's do the green first this time, because green may be more dense than yellow. So let's add green. Again, we're going to add this slowly. Oh man, I think my blue and my green might have mixed up. Oh, we were so close. That's okay, let's try it again. Okay, we're so close, guys. So we still think red's are densest, right? Should get a little more red in there to get rid of some of those bubbles. Okay, all right. So there's our red. Pretty sure red's our densest. Now let's do green. Let's try green next. Look at that. Let's add a little more green. Okay, let's try that on. Okay, you see, our red is definitely denser and the green is definitely less dense. Awesome. Now let's add the blue, because we know that blue is more dense than yellow. That was for sure. That's awesome. All right, I think we got this, guys. All right, you see that? See those three layers, red, green, and and blue. Oh man, that's perfect. So now our last one must be yellow. That must be the least dense of all. Sorry. Look at that. See that? So we have our vertical structure of the ocean. The most dense was the red, then the green, then the blue, then the yellow. Do you see how when there are different densities, they literally remain in their layers? The entire ocean is stratified just like this. So if you're trying to figure out your salt concentrations, the densest salt concentration is at the bottom, right? And then they get less dense as you go up. So which one of these is 0% salt? Which is 5% salt? Which is 10% salt, and which is 15% salt? You be the judge. Awesome. Any questions? Good job, guys. Look at that. Looks good, yeah? Nicely done. Good luck with the rest of your lab.